Problem 2 from 2008 is a really nice chance to go back over what happens when we have resistors in series and parallel, and also what happens when we add either a capacitor to the circuit or an inductor to the circuit, okay? So here we have 1500 volt source, 200 ohm resistor, 300 ohm resistor here in the split, 100 ohm resistor here, and we're going to put a different circuit element right there between A and B. In the first part, we're going to put a 50 ohm resistor here. So the 50 ohm and the 100 ohm are in series, so that makes 150 right there. That 150 is now in parallel with the 300, so I'm going to use 1 over 300 plus 1 over 500 is equal to 1 over REQ. We remind ourselves, after you solve this side of the equation, you have to flip it. You have to take the reciprocal. We get an REQ there of 100 ohms. Now we've got a 200 and a 100 in series, so the total resistance is 300 ohms. They're asking us in part A, 1, 2, and 3 to figure out the potential difference across R2. So that means across this guy. So I figured out the current through the entire circuit. That's going to be 5 amps. So I'm going to have 5 amps here. 5 amps here is going to give me a potential there of 5 times 200. So this is 1,000 ohms right here. That means that these both must be 500 volts. 500 volts because they are in parallel. So the resistor 2 right there has a voltage of 500 volts. Now when we put an inductor inside of there, there's no current in R3 at the start of this problem. So at the very start of this problem, there's going to be no current inside of R3. So this side of the circuit is completely shut down. So now I have a 200 ohm resistor and a 300 ohm resistor. They're in series. That makes 500 ohms. Use that to figure out the current is 3 amps. Figure out the voltage again. That 3 multiplied by 300 is going to be 900 volts. Okay? When we put a capacitor right here, we do have a current through this region, but there's no voltage over this capacitor at the start. We start to charge it, but there's no voltage there right at the beginning of the problem. So now I have the 200 ohms, and now the 300 and the 100 are in parallel. So 1 over 300 plus 1 over 100 is equal to REQ. We get an REQ of 75. Now I have a 75 and a 200. That's going to make 275. I figure out the total current, which is 5.45, and I'm going to figure out what is the voltage here, because this voltage in the 75 ohm resistor is the same voltage that's here and here in R2 and R3, and I get an overall voltage of 410 volts. Dramatic pause on this. Again, normal problem when we put a resistor here, and it's just a big resistor problem. Inductor, there's no current in this region at first. And now here there's no voltage in this region, but there's still R3 acting. Okay, so keep in mind the inductor and the capacitor. Let's move on to the other whiteboard. Very easy to finish off the problem. They just want to know, what does the current look like for R3 when we are in the resistor across AB, the inductor across AB, or the capacitor across AB. When it's just the resistor, the current is steady. It's not changing. It is a steady current the entire time. When it's the inductor, it starts at 0 current, and then it is going to ramp up to a steady current. It's going to become steady. When it's the capacitor, the current is going to be a maximum at first, and then it is going to trail off asymptotically until it reaches 0 current. Okay, take a look at those 3 graphs. Not too much to remember in this problem. Just keep in mind the difference between the inductor and the capacitor.